In this video, we will be using Descartes' Rule of Signs to find the types of zeros of this polynomial. Okay, so first we're going to construct a table for our data. Okay, we have our positive zeros, our negative zeros, our imaginary zeros, and a total amount of zeros. Okay, right away, the total. We can find the total just by the degree. Since it's degree 3, there must be 3 total zeros. Okay, 3. And here it's multiple rows because these are the combinations of zeros, as we see later. Okay, I'm going to put 2 3s. We might need some more later. Okay. So to find the number of positive zeros, we're just going to count the number of sign changes. And that's going to be your number. Okay, so here we have 1 sign change from positive to negative, from negative to positive, that's another sign change, and from positive to negative. So 3 total sign changes. And one other thing is that it's either this number or off by subtracting multiple of 2. So it's 3 or 1. If we had 10 sign changes, it could have been 10, 8, 6, 4, 2, 0. In this case, we get it easy. So there are either 3 positive zeros or 1 positive zero. Let's continue. Now for negative zeros. Okay. For negative zeros, we're just going to do f of negative x and apply the same rule. Okay, so let's plug that into here. That's going to be negative x cubed minus 2 of negative x squared plus negative x minus 7. So every instance of x we see, we put in parentheses and put in negative x. Okay, now I'm validating this. The question of whether to keep this negative is determined by this exponent. If it's odd, we keep it. If it's even, we remove it and make it positive. Okay, so negative x cubed. Alternatively, you could just multiply it out. Negative 1 times negative 1 times negative 1. These turn into just 1 times negative 1. Okay, that out of the way. Negative x cubed minus 2 negative x squared. So x squared plus minus x, that's just minus x, minus 7. And in this case, we don't see any sign changes, so there are 0 negatives. Okay, and here for our total is the combination of positive zeros, negative zeros, and imaginary zeros. So to find a number of imaginary zeros, we just subtract the positive and negative from the total. Okay, so here, if we already have 3 positives and there's 3 total, there must be 0 imaginaries in this case. Now to the next case. There's 1 positive and a total of 3. There must be 2 imaginaries. Okay. And that's how you use Descartes' Rule of Signs on polynomials.